Hi, good evening. Good evening to everyone. I hope the online students can also hear me. So, I'm Bhavna Khurana. I am yours, if you have decided already, mathematics optional teacher here at Vajira. Um, and I've done my master's from IIT Delhi. I've been into teaching for about 25 years now, with experience in Delhi University colleges and UPSC in special, what we're doing now. So I'm going to answer your queries in a while. First, I need to tell you what maths optional is all about. Okay, the general questions that I think people would have in their mind for mathematics as an optional. I'm not going to go into the nitty gritties and the detailed subject wise sharing of that. Why? Because it's available on the website. You go to Vajiram's website or any website for that matter, you can look at the syllabus the way it is supposed to be. So, some general outlines I'll be telling you, then I'll be telling you how I understand the subject, how I understand what the syllabus is like, what is the requirement of the subject, how are we going to go around doing our classes, and then I'll take up queries, if any, towards the end. Is that okay? Right? So I'll begin with what I have to do here. All right. So some general guidelines first. So your optional subject, GS is common for everyone. Optional one chooses. As the name implies, you have to make an informed decision whether you want to choose mathematics as an optional or not. But the general rule that is applicable for any optional is that there are going to be two papers that you have to attempt. So there is paper one and there is paper two. Both are going to be from the subject that you choose. So talking about mathematics in particular, both will be 250 marks each. And the exam happens on a single day, so there is a morning shift and then there is like an afternoon shift in which you have to attend this paper. The syllabus, if you ask me, that ma'am, what is the level of this subject? So you've all done mathematics till school for sure, and also in college. So that is one requirement. If you have had any kind of a graduation where you've not had any maths subject, not even one single maths topic, then I would advise you not to take maths as an optional. If you have done engineering, that is, and if you've had any paper of mathematics, whether it is calculus or differential or numerical, you're more than welcome to join the course. You've done BSc with maths as one of the subjects, or you've done an honors course in mathematics, or even if you've done things like honors in physics but you've had maths papers. So basically what I'm saying is you have to be in touch with the mathematics syllabus. From your school level, you can't straight jump to optional. You have to have this last 3 or 4 years of graduation that you have done, some amount of maths that you have done. Now everyone would have done different level of maths. Somebody who's an honors student would do, say, algebra more in detail. Somebody who's an engineer would probably do more like numerical analysis or more linear programming. That is irrelevant because I'm going to start teaching every topic from the scratch. Why? Because I can't individually understand what your requirements are. So let us assume a ground level to start doing the work. And then, as and when the classes proceed, I take up to the level that is required from the exams perspective. All right. So whether it is algebra or analysis or differential or numerical, we are going to start everything from the scratch. However, there are some basic requirements that are required, that are expected out of you. Like I said, you've had to have maths as one of the subjects in your graduation. Okay, it doesn't have to be an honors degree, but it has to have some amount of maths. Second requirement is that you must have a passion for the subject. So I hope everyone would agree. Now this is a small group of people, and I can very well say that the fact that you're sitting here means that you'd had some sort of a love for maths. Am I right in assuming that? Have you also had experience where people say, oh my God, what is maths all about? Since school, have you had any friend who didn't like maths at all? Or did you come across people who have like a phobia for maths? Have you come across such people? Okay, let's keep this as an interactive session because if you keep listening to me, then I'll be like a lecturer. Let's keep it as an interactive session. So, have you had students or your friends or your family members who have had this phobia sort of a thing for maths? Yeah. You also prayed, you're thought of as some higher level kind of person when you say that you want to choose maths as an optional. If that has happened with you, we obviously enjoy the kind of attention we get, but then we also realize why we like maths is because there's some core fundamental on which a concept is based. Once you get a hang of the concept, then it is about sitting down and fill in the blanks, sitting down and practicing. And when you practice, you have to have a kind of a categorization in your mind. Let me take a topic like integration. There are about 50 formulae of integration. Huh? Remember R.S. Agarwal, NCERT, R.D. Sharma, or any such book. 50 formulae. Now, if you tell any sane person that you have to cram up these formulae, he or she can very well faint with the amount of work that is required to cram them up. We didn't have to cram them up. We understood when to apply partial fractions, why you apply isolate, when do you make some substitution. However, it was still sometimes trial and error, isn't it? When you get stuck, do you immediately look at the solution or you keep trying? We keep trying, right? And that trying process, the process of trying to do a question on your own, gives you a kind of a very satisfying kind of a feeling, because you feel that you have conquered that particular topic. However, even if you've done 1,000 questions on some topic, you can still come across one new question in which you might just get stuck. Or somebody who's not even as well practiced as you are can think of a substitution which evades you. You can't think of it, but somebody just tells you put x equal to sine squared theta, and suddenly, like magic, the calculation becomes very, very easy. So when you have a passion for the subject, the amount of effort that you want to put in practicing does not look like a huge amount of effort. It doesn't look humongous. It looks like, okay, every day we will have to sit down and practice. So when I say I will be taking, so our class timings will be from 7:30 to 10. I'm writing 10 to be, I'm being a diplomatically correct here because I'm writing 10, but it could be close to about 10:30 sometimes, because towards the end, when you're doing a particular topic, you have to kind of wind it up. You can't leave it for the next day. This will be 6 days a week. You will be required, like I said, to know the basics. So what are the basics that I expect you to know? I expect you to know things like differentiation. Now, when I say differentiation, I don't mean that, okay, go back home and open some book of class 12th level and do all the questions on differentiation. No, I just mean that you must be familiar with the concept of differentiation. And if I ask you that, do you remember formulae for x squared? What is a derivative? I'm going to not right now ask any complicated maths, okay? Because that's not what the point is here. But if I say differentiate something, even if you don't remember, at least you have some sort of a formula sheet or some sort of a way to, just Google and find out. You won't be scared to do the differentiation. Similarly, you need to know integration. This is class 11th, 12th level is what I'm talking about, okay? And then another topic that I think you must know from the basics is matrices and determinants. Okay, if these 2-3 topics are on your fingertips before you come for my classes, then that is all that you require. You don't need to know any topic from the syllabus as such, all right? So 2.5 hours classes, 6 days a week. And apart from this, I would expect you to put 2 to 2.5 hours every day at home. What will you do in this 2 to 2.5 hours? This 2 to 2.5 hours, every class will have to be revised in about 1 hour. Now, when I take a 2.5 hour class, I will be doing a concept. Suppose I'm teaching you, I don't know, let's pick up linear algebra. So I'm going to tell you the concept of linear algebra. Then there are some theorems that I have to do. How do I do the theorems? I have to face my audience, which is my students, okay? I don't like, and you would appreciate why, I don't like going to the board and writing everything very neatly on the board. Why? Because notes will be given to you for that matter. You don't have to refer to the notes also when the class is going on. You have to only listen to me the way you're listening to me right now. I won't write a single sentence unless I'm prompted by someone. So first what I'll do, I'll give you the concept, then I'll give you the reviews if required, like what are the other things that you might require in this. And then we will do an interactive kind of a session that maybe somebody would suggest what the next line should be. You can tell me what we should do now, how to write down what is given, what do you have to show. Because every theorem or every question for that matter is a bridge between what is given and what you have to show. So every theorem or every question is something is given to you and you have to do something to it. Even integration question is like that. Some function is given, you have to integrate it. A theorem is given, some information is given, and you have to show something. A theorem is basically a sequence of logical steps through which, from the given information, you have to deduce what you have to show. Nothing from outside can come. Only what is given has to be utilized properly and resourcefully. The meaning of what is given should be completely clear in our minds. So every theorem, we will be doing an interactive kind of a session. So a theorem might take me about half an hour to do in the class. But once you have understood the theorem, I'll give you, say, 5 minutes to revise it also in the class. I'll say, okay, now go through the steps. Or maybe refer to the notes, because sometimes when I'm writing on the board, I don't like people scribbling when I'm teaching, because all your senses cannot work simultaneously. If you're busy writing, then you're not listening very carefully to me. But if you're listening very carefully, back of your mind, you're thinking, oh my God, how will I write all this? How will I remember all this? Ma'am, will she give us time to write? For that, you will get notes for every topic. Now, This kind of booklets will be given to you. Now they're all handwritten booklets. Now when I say they're my booklets, are written by me, so they're not copied from anywhere. However, this is mathematics. If I write a theorem, I have not proved that theorem. Somebody else has proved it, but I have written it the way I understand it. I have written it the way I want you to understand it. This is still about, I would say, about 70-75% of what I do in the class, but remaining 25%, questions also will be done on the board. And theorems proof is same here, same as in any book also. I'll give you about 5 minutes to go through it to see if there's any step that is not clear, if you want to ask me anything or whatever. But when you go back home, you have to comprise that knowledge and do it within, say, 10 minutes. A half an hour theorem, which is done in the class, at home while you are revising, should not take you more than 10 to 15 minutes. Do you agree with that? Because obviously you're listening to something for the first time. It will take me time to talk to you. I'll ask you, is this clear? Then somebody will come up with a doubt. You may not have a doubt in this, but tomorrow you may have a doubt. I'll have to answer everyone's doubt, including the online students sometimes. And it does take me time. Sometimes people write a whole email on the this chat, and I take 5 minutes to read also. You have to give that kind of a breather, because every day, if you're having a 2.5 hour class, it has to be interactive. Otherwise, it can be very well recorded lectures, So, but when you a half an hour theorem, which has taken us about half an hour to do, is revised at home, it takes you about 10 minutes. So if proportionally you decrease it, 1 hour at least you will take to revise the lecture. Correct? I said about 2 to 2.5 hours. What will you do in the remaining time? Every booklet, there will be some assignments. Every booklet, end of every chapter. Because I can give you a list of books. In fact, on Vajiram's website, it's personally given by me. This is a list of books that I have recommended. I follow about 10 books for each topic. I've given you the best 2 or 3 books, but you don't have to really purchase any book right now, because purchasing a book means you'll have to also have a duty to read it. Now, it's very easy for me to say, go to the library or go to the bookstore and buy all the books. The exam will come from there. That I think everyone understands. Maths questions are not going to be made up. They are going to come from standard books. And even if they're not exactly the same, like if you solve 100 differential equation questions, will you remember which exactly question did you solve? No, you will just know the technique. You will have to understand the technique and do it in the exam. By luck, sometimes you have just solved a question and that comes. Sometimes people also remember the answers. That is very good luck. And that happens also, by the way. In 1 or 2 questions, you'll be like, oh, I remember this answer because we did it in the class. Now, some of the questions come directly. When I say directly, I say from the notes, but the notes are from some books or the other. So that means directly picked up from the book, which is good. But we need to learn the concepts, all right? So when you are going to go back home in 1 hour, you're going to revise the lecture. And in remaining 1 hour to 1.5 hours, you're going to do assignments that I ask you to do based on that particular topic. It will be given in my notes. So first you'll do that. Second option, the second level that you have to do is the PYQs. Now, if you're expecting that I'm going to sit down and solve the entire PYQs and give it to you, I can do that. That is very easy, because I have to just sit at home and as a teacher, solve everything, give it to you. But me solving, does it help? Or you solving helps? You have to solve it. How will you do it? So when I'm almost done with 50% of a topic, I'll announce in the class that today I've done till today, we have finished about 50%. Go back home and refer to the previous year question papers. Now, refer how? Don't go to any website which gives you the categorization of questions. I know what is available on Google, okay? So don't type differential equation questions and PYQ maths optional, because that is spoon feeding. That is like everything ready-made given to you. You look at the feel of the question paper. When you're looking at the question paper, you have to recognize, is this differential equation ordinary or partial? Is it even differential equation? Sometimes there's a word problem that comes, whether it is LPP or differential equation or algebra. Shouldn't you have the sense to understand that this topic is being represented through this question? Tell me, yes or no? So why should you look at categorization? You should look at the entire question paper, because the more you look at the question paper, the more feel also you get of what is in store for you. Nobody is expected to do all questions, but you have to be able to recognize the questions right in time. So in the exam hall, you spend 5 minutes reading. You should have the brains and the understanding to circle, okay, this is differential, this I know, this I don't know. Maybe there's some question that you don't know, but at least isolating the topics will be a very big help in the exam. So you will have to do revision, then you'll have to do my questions and the assignments, which are end of every chapter almost. And then you will have to start doing the PYQs. And then when the topic gets over, we will have a tutorial kind of a session where we do all the doubts of the assignments, where we do all the doubts of the PYQs. And suppose you say that, okay, 5 people only have a doubt in some question, rest everyone has done it. What will we do then? I'll also be sharing some solutions given by the students. Obviously, I have solutions written by me also, by previous year students also, but it has to work like a team effort, you know. So somebody gets up and says, ma'am, out of those 20 questions, I was able to do 18. I'll say, very good. Try the remaining 2, otherwise we'll see. When the topic gets over, by that time, if you're able to complete the entire assignment, I will take your assignment and distribute it with everybody or share it with everybody so that everybody has a sample answers also available. You can match with what your presentation is. If nobody can do it, then obviously I'm here, I will provide the solution of that particular question. So it becomes like a very something that you look forward to, because you want to have your assignments submitted and checked by me, right? So, and that will happen only when you're able to complete it. And you can't complete it in one go sometimes. You can only do about 5 questions today, 7 questions tomorrow, then 3 questions. End of every topic, we will have, like I said, a tutorial where we sit down and cover all the doubt clearance class kind of a thing, right? That is what so classes are going to go according to that, all right? So 2.5 hours, 6 days a week, booklets will be given, notes will be provided to you. Reference material in terms of books, it's already up on the website, but I discourage you from buying anything right now. Once my classes begin, I will tell you 1 or 2 books that I think you should have, but nothing right now, nothing right now. Because just buying a book and keeping it in your study table is not going to help you. You have to be in need of looking at a book for certain topics like differential equations. I would say that you'll have to buy the MD Raisinghania book that is available, because it's that thick. It's like more like a question bank. You don't have to look at the solutions. You don't have to look at the concepts. Concepts we'll do in the class. But for practice, you obviously need to do more and more and more questions. So things like that we'll be sharing. I'll be sharing in the class. Is that clear to all of you? Right? So the class schedule is clear to you. I think that is fine. What is expected out of you? Every day revision is expected. Like, I can't reiterate this point enough. You have to understand that I can teach, but if you don't revise, then it's not going to be helpful, because it's like any optional classes like that. But for maths especially, I can tell you this is more like a military program. Okay, once you join, it is only like come sit down, but it's every day rigorous 2.5 hours. Classes are hectic. It's not a joke to either teach for 2.5 hours or to study something brand new for 2.5 hours. Now, all the topics may not be brand new. Everybody has heard of differential equations, right? Basic differential equations. People would not really get very tired that day. But differential equations booklet, we'll do about 15 pages in 2.5 hour class. Modern algebra, I'll be able to do only 5 pages in 2.5 hours. So the ratio, it's not numerical analysis, easier to do because you have your scientific calculator, bisection method, Newton-Raphson. Even if you haven't done these methods, I can assure you that when we do it, it's actually fun. In one day, you can do 4 or 5 methods. So every topic does not require same amount of attention from my end. And this brings me to what the course content will look like. Okay, let me just keep taking some classes also, some questions from the online students. Yeah, so online students will also be getting the booklets. You will be getting the booklets. We'll be posting it to you once the classes begin. And till that time, we will obviously, you'll have a way in which you can access the notes, so there is no problem. Yeah, so Pragati, let me just come to that, and then I'll tell you how we're going to cover. So like I said, I'm not going to discuss the entire syllabus in terms of how paper 1 and paper 2 are. That you can do at home. Can you Google search and see paper 1, what it is constituting, and paper 2, what it is constituting. I will tell you, according to me, what are the 3 divisions of the entire syllabus. So paper 1 and paper 2 combined, according to me, should be divided into the 3 categories, which is algebra, analysis, and other applied topics. I would request you not to write anything right now. Let me have an interaction for 5 minutes, then I'll give you 2 minutes to write down if you want to, okay? All right, now please listen carefully for the next about 5 minutes. Algebra, analysis, and applied topics. So like I said, I'm reiterating once more, I'm not telling you the syllabus, paper 1 and paper 2. That you have to, now once you have decided you have to take maths as an optional, go back home today and get a printout of the syllabus, keep it ready with you, go through it so that you get a hang of what comes where, okay? I will in between keep telling you this is paper 1, this is paper 2, but then it doesn't have to be absolutely based on what I'm doing right now. I would be predominantly, by the way, teaching in English. In between, I have sometimes I digress to using my mother tongue, but then I come back to English because that's the medium that we are all appearing in. You have to get used to writing also in English also. Teaching also has to happen in English also. But all right, now just give me 5 minutes before I take any other doubt. So algebra is made up of 3 basic things, okay? This is groups, also known as group theory, rings, and the third is vector spaces. Now, groups and rings together forms the first unit in paper 2. This is the first unit in paper 1. Now, group theory and ring theory together is given a very nice name. It's known as modern algebra. Also, abstract algebra. Okay. Now, a quick question for all of you. Have you heard about modern algebra? Any rumors about modern algebra? Anyone? What are the rumors you have heard of, or what is your perception of what modern algebra is? Lengthy and theoretical and proof based. Okay. Anything else? Anybody? Yeah. Not intuitive. Non-intuitive. So that means you're saying it's not intuitive. There's a lot of cramming involved. Is that what you're saying? Hard to imagine. It's too hard. Okay. Piece of cake. I don't think anyone has said that about modern algebra. I don't think so. Even now, after about 25 years of teaching and studying, I can't say it's a piece of cake. It's not. Modern algebra or abstract algebra, it is very intuitive. It's actually very intuitive. However, it has to be taught from the scratch. It is like you're not supposed to know anything about it. Even if you've read modern algebra, forget about it when you come for my class. Like nobody knows anything about groups, okay? When we start doing groups, we do it in a way where we can start visualizing. Now, but by visualization, I don't mean I can make some structure. It's not like a hyperboloid or a paraboloid or a cycloid. It's not that. It is basically, algebra is known as queen of maths. Queen of maths. So if you can master algebra, where have you done algebra in school? Have you done any amount of algebra in school? So school, you remember what are the topics? So calculus is differentiation, integration, etc. Trigonometry, everybody remembers sine, cos, tan, etc. What was algebra in school? Have you studied any algebra in school? What was algebra constituting of when you were in school? Polynomials, yes. So polynomials, does anyone think polynomials is very tough? Anybody sitting here? How can modern algebra be tough if it is based on, algebra is based on polynomials? Not based on as such, but polynomials is a classic example of what a group can be understood as, what a ring can be understood as, what a vector space can be understood as. So when I would teach modern algebra to you, when I say I will make you imagine it, or I'll help you see why it's intuitive, we'll do it through examples. Once a student understands what is an example of a group, or what is a group, also understand what is not a group. See, there are two sides to the same coin. If you understand what is a group, you have to have great knowledge of also understanding what is then not a group. If something is a group, there are 4 properties. Not a group, what is the problem? If you can isolate these problems, then it becomes very example oriented. Once you get a hang of an example, then you can associate all the theorems with it also. So in the beginning, 2 or 3 or 4 classes, about 3 to 4 classes, rigorous 2.5 hours each day, I do only examples. But those examples help you to understand groups also, rings also, and vector spaces also. So it's like a bridge. Once you start on a journey, then you keep linking the other piece with it, and the entire modern algebra gets done. Yes, it is theoretical. It has to be, because it's, like I said, queen of maths. It's the backbone of maths. So there have to be theorems involved. But theorems do not mean cramming. I can assure you about 99% of the theorems are going to be very, very logical, where you will not require a single line to be crammed. But what will be required? The techniques to prove something. Like we will discuss in the beginning, what is the meaning of proof by contradiction? What is the meaning of it? And when do you use proof by contradiction? When do you actually decide that you're going to do it by contradiction. We're going to discuss different scenarios where we do things like proof by contradiction. There are other proofs which are called constructive proofs. We prove something by constructing it. They say, okay, show that there's a sequence of ideals which converges to a principal ideal. So then I show you how we can create this sequence. We actually sit down and create ideals so that it is converging or whatever you're discussing in that sense. So it is logical. However, it is time consuming. The maximum amount of time that is gone in teaching a particular topic is when I do modern algebra. Once my students have got a hang of modern algebra, I then go to vector spaces. Now, vector spaces is actually, if you say see paper 1, it is written as linear algebra. And linear algebra is made up of two things. One is called vector spaces, which has a direct link with groups and rings. So one does groups, then rings, then vector spaces. Okay. The other component of linear algebra is going to be, what am I writing? Matrices. Right? This is going to be the simpler part. That's why people come up with this idea and say, oh, we know linear algebra. It's not tough. It is quite tough. Only 20% is matrices, which I'm also going to spend only 20% time on it. The remaining 80%, we have to do vector spaces properly. We have to understand that how it is theoretical, even if more questions come from it. It's more applied as compared to groups and rings. But the numerical questions that come from linear algebra are based directly on your understanding of how well you understand the theory behind it. If your fundamentals are strong, only then can you attempt all kind of questions. Okay, and in UPSC, we have seen a pattern in the last 5, 6, 7 years. Now, there is a concentration on theorems coming from linear algebra, which is, I think, a very positive development, because questions can be done, but the style of presentation of questions also tells the examiner how well you know the theory. So while teaching you, I will also be concentrating on your style of presentation, because that makes all the difference. 2, 3 ways in which style of writing would be improvised. One, when I say I give you my booklets, they are handwritten and they're not copied from anywhere. Of course, they're maths theorems and questions. So the questions will be from somewhere or the other. Sometimes, obviously, the solution also would resemble a book. But theorems, I assure you, are the way I have understood my maths. And when you look at the presentation, you realize why it is easier to decode it as compared to decoding it from a book. So by exposing yourself to I wouldn't say a perfectly written solution, but I would say, yeah, I mean, a well-written solution, you learn how to imbibe, you learn those qualities that are required to present the solution yourself. Second would obviously be, like I said, assignments. If you do assignments, you can submit it for checking. I can't check individual assignments, but then if you are the first one to complete the entire assignment, I will have to go through it before I share it with everyone. So there's this sense of competition, and you are competing with each other. It's not a joke. This is not, we are not learning it for pleasure, are we? Or is this a PhD program where you're just doing it your own journey? No, it is a competition after all, but it has to be a very healthy competition. Each one is going to help the other person, but keeping in mind that this is also the first person to finish the assignment is the one who gets to present the answers to me and therefore share it with everybody and so on. So that kind of a thing would continue. Coming to analysis, analysis is constituted of, one is calculus, which comes in paper 1. In calculus, you have things like, so what is calculus and why is it coming under analysis? The word calculus comes from, okay, give me a mathematical word related to calculus. Calculus, calculator, calculations. So what is calculus? Calculating different things. What are we calculating? Limit, calculate. That's calculus. Integrate something, calculus. Differentiate something, calculus. So why am I writing it under analysis? Because first you have to understand that calculus is based on something called real analysis or complex analysis. Everyone knows, well, actually you don't, but that's my first lecture, so I wouldn't go into that today. But what are real numbers? You have an idea? So if you're joining my classes, that's the homework for today. Every day I said there'll be a homework, no? So the homework is when you come on 15th, I'm going to ask you what are real numbers and you have to answer that. Okay? Homework 1 given, maybe 5, 6 more homeworks I'll add today. What are real numbers? What are complex numbers? So some idea of real and complex everyone has for sure. So 5 by 3, real number or complex number? Real. Not everyone is very confident. 5 by 3, real or complex? Real. Root 5? Real. Okay. 5 iota? Yeah, so the presence of iota right now, that is the amount of information. So when you do real analysis and complex analysis, Then you understand what has to be calculated in calculus. So in real analysis, we study real numbers, then we analyze them. Analysis basically means analyze. What are you going to analyze? Different properties. Like what? In real, we are going to study things like sequences and series. We're going to study complex analysis also, and from point of view of sequences and series. Then we are going to study in real analysis, we study something called Riemann integration, or Riemann integration as it is pronounced in several places, but more like an Indianized version is Riemann. So Riemann integration, what is Riemann integration? Now everyone is supposed to know integration. What is Riemann integration? It's name of a mathematician associated with it. But what is it all about? It is the theory of integration. Where does integration come from? If you don't understand the root of something, you can't understand the applications of it. So if we learn how to integrate something, that is a tool. Integrate. That even a software can do. You know, there are softwares available. Let's look at the practicality of it. Today's world, we don't need to really sit down and integrate anything. A software, MATLAB or something would integrate something for us. But who has developed that software? Someone with knowledge of Riemann integration. Because, tell me honestly, you guys know integration, right? So if I ask you a simple question of integration, like integrate, I don't know, sine x or integrate x square, you know the answer to that? Keep the answer to yourself. I'm not interested in the answer. But you're looking happy with integral of x square, everyone knows. Now just tell me one thing. Can you give me a name of a function, or can you name a function which cannot be integrated? At school level, so I like the blank look that everyone had on their face for a minute, because at school level, all the questions were integrate the following. And there's a list of 100 questions I can give you which you can integrate. But has anyone thought, are there functions which cannot be integrated? Yes and no. Discontinuous functions can be integrated, in fact. So if you have, you know what I'm writing here right now? What is this? Greatest integer function. So the graph of greatest integer function goes like that. It is discontinuous. But if you have to integrate it, you can. Because if I say from 0 to 10, you integrate. Give me, how would you integrate this? 0 to 1, 1 to 2, 2 to 3. Yeah? This is called interval theorem. And we prove it under Riemann integration. So very simply speaking, till today, if anybody had to integrate something from 0 to 2, you can write this as 0 to 1 plus 1 to 2. Everyone has done it also multiple times. But why can you do it, or what is the logic of splitting the interval into two intervals, is what you prove when I do Riemann integration with you. This is part of analysis. Once you learn how to integrate and what are the logics of integrating something, because when you integrate, sometimes, okay, you understand this when I just write integral of x as compared to integral from 0 to 1 of x. What is this one called? Indefinite integral. And what is the other one called? So what is the connection between them? Is there something called indefinite integral? Actually, definite integral is a shorter chapter in school. Why? Because once you learn how to integrate it, after that, what do we do? Just put the, yes, upper limit minus lower limit. But what is the logic? And when I say upper limit to lower limit, when I say 0 to 1, what is the interval in which I'm working? Is it 0, 1 this? Or is it 0, 1 this? Close 0, 1. But have you ever wondered when I write 0, 1, whether 0 or 1 are included in the interval or not? Suppose they're not included. Even then, will the value of integration change? So these are the questions. You don't have to answer them. You don't know the answer of that. I'm posing questions. Why am I posing questions? Because I need to tell you that when you say, people walk up to me and say, I know calculus. Okay, very good. How can you know calculus if you don't know real analysis? Because they are partners. They go hand in glove with each other. So I don't do calculus first. I'll do real analysis first. And I'll spend more time on real analysis because the new questions are the ones that you need to spend time with. When it comes to integration, I'll say, okay, this is this we'll do, and then go back home and do 100 questions. When I do Riemann, I will only do theorems in the class. Today's class, if I've done the theorems, homework will be only to revise the theorems. But if I do questions today, then homework will be do 100 questions based on calculus. Okay, so every class is going to be a mixture of concepts and of practice. Where you need my help is where I'll be helping you more. Where I think students are supposed to be equipped to handle it themselves, like actual integration and all, we just share the answer with you if you're getting stuck, or we encourage you to actually, I would encourage you to go back home, get stuck, plus please do it yourself. Until unless you learn the techniques of the trade yourself, providing you with answers is not going to be helpful. Discussing the answers or discussing the alternatives will be very, very useful. So you do understand that when I write analysis, calculus also comes under analysis. All the books of calculus, I wouldn't say all, but 90% of the books of calculus are the analysis books. So Real Analysis by Shanti Narayan has calculus topics. Okay. Mathematical analysis by Apostle, or analysis, Apostle is called calculus, but mathematical analysis, all these books that I'm naming, whether it is analysis or calculus, they have a mixture of topics coming from analysis as well as calculus. Okay, so calculus and analysis are one and the same thing. In analysis, you do more of theory, analyze things like limit, continuity, differentiability. What is the logic of finding the limit? Why do you say some functions have a limit, some functions don't have a limit, all that. When it comes to actual application of it, we do calculus there. Is this clear to all of you? Then there is also another, I would name it as applied, but I can also write it here. This I would write in between the two. Another topic that has a word analysis associated with it is called numerical analysis. Have you heard of numerical analysis? What are the topics that you do in numerical analysis? Gauss-Seidel and bisection method, and there are algorithms, and so basically you learn this. I'm just looking at the word analysis. What are you analyzing there? More importantly, we do it under applied topics because there's hardly any theory here. There's hardly any theory, but still there is analysis because it requires real numbers, the logic, the understanding of real as well as complex numbers. Numerical analysis comes with numerical analysis and computer programming. When I say computer programming, you don't have to be scared at all. There are just algorithms that are required, some flowcharts, some basic idea of how the methods behave, and some amount of Boolean algebra. Okay, so Boolean algebra is truth tables, true, false. Like I said, I'm just sharing so that everyone has heard of something or the other. So you feel that, okay, some amount of syllabus is something that you've heard before, but you may not have heard of it. That's okay. We'll anyways be doing it from the scratch. Okay, I'll take up the questions a little later. Don't waste your time writing them right now. But all right, now let's come to the applied topics. In the applied topics, you have, first of all, so I'll write here, the applied topics are, okay, how many topics have we covered here? You know how many modules you have total in your paper? There are 13 modules that you have to do. All right, so how many have we covered? Groups and rings is 1. Then you have linear algebra, that's 2. Calculus, real analysis, complex analysis, numerical analysis we will write under applied topics once more. And then let's begin with, the next is, what is this? Ordinary differential equation. Nothing ordinary about it. Nothing ordinary about it. It is actually more complicated than even its friend and cousin. What is PDE? Partial differential equation. So what is ordinary and what is partial? Ordinary differential equation is when you have y just as a function of x. Some car is moving and it is dependent only on x, so the y depends only on x. But partial differential equation is when y depends on x1 and x2. But you can't stop here because there is not super PDE available. There is ODE where one variable is dependent only on one variable. PDE is an extension of this where it may depend on n number of variables. All this comes under partial differential equations. Differential because there has to be a derivative. So when there is dy by dx, this is ODE. When there is a, what am I writing right now? Del y by del x1, this is called partial differentiation, which by the way also comes in calculus. So in calculus, you have to do differentiation, ordinary and partial. So once we understand calculus, we can understand ODE, PD, at least the background that is required to understand it. ODE and PD, both are the applied topics and they cover, ODE is in paper 1, PD is in paper 2. There are a lot of similarities and overlapping between them, but then obviously they have their distinct way of functioning also. One topic is almost common between the two. So when I teach that, I do it in one go. I don't teach according to, let's finish paper 1 first, then paper 2. No, I teach the way I'm writing, because topics that are associated with each other more as compared to the other ones have to be done together. Because in your mind, there has to be a sense of correlation that has to form between the two. So I'm not going to teach paper 1 unit section A, paper 1 section B, not like that. I will do it the way I understand the syllabus should be. And you also are going to revise it like that. Once, of course, the course gets over, then I'll ask you to concentrate on section-wise studying, because ultimately you have to choose questions from the sections also. Then you come to, what is the next? LPP. What is the full form of LPP? Linear programming problems. So at some school level also nowadays LPP is introduced. I think graphical method and all we do at school. Do we do it? Here we do more advanced levels. We do simplex method. You might have done simplex before, or you may not have, but it's an applied paper. It doesn't take too long to do it. There is transportation problem, assignment problem, and duality. So there is no game theory is not there. So if you've done game theory, that is not part of LPP. Then let's see, numerical analysis I've covered. The next is analytic geometry. This is predominantly 3D geometry. Okay, so you start from sphere, cone, cylinder, you go on to paraboloid, hyperboloid, equations of second degree or more. And after a while, you have to obviously visualize till hyperboloid, ellipsoid, and so on. But after a while, it becomes very mechanical. You have to just know what is the meaning of a homogeneous equation. Again, these are the tricks and things that we learn in calculus. We understand what a homogeneous equation means, So once you understand that, it is mechanically going to be solved. You don't even have to draw very fair diagrams here. A rough diagram of a cone, everybody will be drawing the same. But yes, what is the vertex given? How is a tangent going to be drawn? All that visualizing will be doing as far as possible. Sometimes you just pick up the notes and try to make a cone out of it, or like a cylinder out of it. But then cylinder that we think of, how do we visualize a cylinder? We visualize a circle, and then we visualize something like a pillar sort of a thing. But what if it is not a circle, but something which is twisted? Can you imagine a cylinder like this? Something whose base, suppose I draw a circle around me, and then, just have lines which are enveloping me right now. And then imagine if it's not a perfect circle, but an ellipse, right? Even then you can have a cylindrical figure. So what cylinder you think of a cylinder is a standard cylinder. We will be doing generalized ones also. So analytical geometry is the other concept. How many have we covered? Let me just have a, so 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is one that I'm missing here. The vector calculus. Now again, you may wonder, why is vector calculus being written here? It can come under the category of calculus also. See, I can do subdivisions. Can you see calculus? If something is called calculus, it should come with calculus, right? But we don't have to do theory too much in vector calculus, so we do it as applied. So there is basic vectors. You don't have to be from a science background to understand vectors. You understand something which has magnitude and direction is known as a vector quantity, but that's all that I know. I mean, after that, I'm going to teach you how to add them, what is the meaning of multiplying them if we can multiply. Also, can I show you something very interesting? Can you locate this word in any other topic that we've already written? Where? Calculus has been already written. Where have you written vector? We have written it in vector spaces. So vector calculus has to have a relationship with vector spaces also and calculus also. What is the relationship? I'll be establishing. So that ultimately the syllabus is not 13 topics. It boils down to 2 or 3 topics. There's algebra and analysis actually. These are the 2 pillars on which the entire maths is based. You understand? See, OD, you may wonder, does not have any algebra, ma'am. It does not have any analysis. It has a lot of analysis. I'll show you. If you can understand 2 basic topics, no, you can understand algebra well and analysis well. Everything else is a piece of cake. It's a cakewalk. But you have to know algebra and analysis very nicely. And if I can draw connections, see, if you find a familiar face somewhere, do you feel happy? Provided you like the familiar face. That keeping that you would see, if you meet a relative in a mall or something. I think that's a bad example. With today's generation, we don't like meeting relatives. Okay, say a friend or something. We generally are happy when we see familiar faces in an unknown surrounding. Am I right? Just agree to this, because I would be happy to see a familiar face. But I'm saying that if you're doing vector calculus and you're like, oh, it has connections with vector. Oh, I've already done vector. You feel happier. Oh, it's called calculus. But why is it called calculus? That is my work, to explain to you how they're connected with each other. Once we understand it, the syllabus doesn't become shorter by that, but it becomes more interesting because everything gets covered in a capsule sort of a manner. That okay, you understand this, then just link the two, you understand the third topic in a way, and then you do new things in it. So in vector calculus, we learn how to add, we learn how to multiply, then we again learn how to differentiate because it's calculus. We learn how to differentiate, then we learn how to integrate because calculus means differential calculus, integral calculus. So integrate how? We can have a single integration, then we can have a double integration, then we can have a triple integration also. So we learn single, double, triple, then we understand line integrals, then we understand flux integrals. There are about 13 categories of integration we will be doing in the syllabus. 13. What is line integral, what is double integral, what is a flux integral, how is it connected with, and there are 3 theorems: Green's, Stokes, and Gauss. They connect all the integrations that you do. Okay. So now when I do integration, what do you think we're going to do in the class? I'm not going to come and sit and solve every integration question for you. No. I'll be teaching you the technique. We will be doing questions in the class. Then you will be going back and doing more questions. You come back, I'll be giving you another concept. You go back, do the questions that you did from the last class, based on the new technique. Like instead of doing this double integration, can we convert it to a line integration and then do it? And the answer is yes. One out of these theorems, Green's, Gauss, Stokes, help you to convert a double to a triple to a line integral to a volume integral to a flux integral. So we first understand separately all of them as tools. Then we understand the cross connections between the two. That is vector calculus. Okay. So how many topics covered till now? I'm not writing it in any order. My notes are much neater than the way I'm writing on the board because I'm more enthusiastic to share rather than this. So let me just check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the 11 maths topics. Then you are left with the physics portion. The physics portion is divided equally into unit 1 and unit 2. That means paper 1 and paper 2. You have dynamics and statics. That comes in paper 1. And you have mechanics and fluid dynamics. That comes in paper 2. Okay, just 1 minute more I'll take about the syllabus and I'll give you time to write it down if you want to. The physics topics, as the name implies, are topics which are based on the physics concepts. Okay, so you need friction, you need to understand virtual work, I just said I don't need you to be from a science background. How many people are not from a science background here? Please raise your hands if you're not from a science background. Everybody, that is marvelous. You're keeping my expectations very high of the group, but there could be some people who've not done physics in class 11th and 12th. Because they've done maths honors. To do maths honors, you don't need to have a science background. By the way, maths is known as mathematical sciences. It is a science, but also humanities students can do maths. There are very few subjects which can be done by sciences people also and humanities people also and commerce people, irrespective of the branch. So be proud of the subject choice that you're making. It's like a universal language. You can understand maths even if you have humanities. So those people, if they end up doing maths honors, they're more than welcome to take maths as an optional. How do they then understand physics? Because they're competing with you guys, the sciences people, 11th, 12th, PCM B or PCM CS or whatever your choice was. Believe me when I say that sometimes people not from science background can do better than you in physics because you need only restricted amount of knowledge of physics when you have to do this. Why are physics topics included in maths optional? Why? Because we don't have to do physics. We have to do applications of maths, which is done through physics. So we don't have to really know the concepts of physics that strong. We do. Of course, we need to know, the reaction is going downwards and if gravity is working here and there's friction and everything. Basic general knowledge will have to be known or shared with you through the medium of the class. But after that, it just becomes a question of integrating. After that, it just becomes a question of differentiating. After that, it just becomes a question of calculating the triple integration or the double integration or something called conservative fields. Now, conservative fields sounds like a physics concept. There's field and it's conservative. No, it is vector calculus. A field is said to be conservative if we have definitions of conservative field in 2D and 3D, which I teach in vector calculus. So physics has to be done in a limited amount of space and time. You don't need to understand physics in its depth. You need to only have 1 or 2 review classes of physics, basics of physics. What are the things that are required? That will give you in a handout sort of a form, and then we'll learn what are the topics that we have to do in physics as prescribed to you in the syllabus. So you don't have to know too much physics. So if you've not been very happy about the physics portion, that is perfectly all right, because you have to do physics from a mathematician point of view. If I'm a mathematician or physics person can come to me and say, I'm getting stuck here, can you help me out? I don't have to understand what is the field in which he's working. I need to only understand, is he asking me to integrate or differentiate? Can I integrate? Can I differentiate? Is it a conservative field? Will I be able to find the integral? Can I find the triple integration or not? That is the work of a mathematician. And that is what all of you are going to be preparing for. You are going to be mathematicians when you're doing this, not physicists, okay? So you don't have to go into the nitty-gritties of it. You have to only handle it from the point of view of the kind of questions that come in the exam. And they're pretty much stereotyped, okay? Of course, 1 or 2 questions in any topic you pick up can be something which is not very easy to sort of cover. That's not true just about physics. That can be true about any topic, okay? So it has nothing, physics is nothing to be scared of. It is something which is done in, both the topics combined together are done in about 20 classes. As compared to modern algebra alone, not vector spaces. Modern algebra alone takes me about 28 to 30 classes. Compared to that, this is nothing. It's going to be a piece of cake. All right. So these are the ways in which the syllabus has to be understood. You have to understand it as algebra, analysis, and the miscellaneous applied topics. Applied topics are the ones where mostly questions come from. Algebra and analysis have some theorems also. What is the ratio? About 20% theorems, 20 to 30%, because some of the numericals also are theoretical. I mean, you can say it's a numerical, but it requires so much theory, it becomes almost theoretical. So about 30% will be theory, and about 70% would be numericals. Is that clear? What is the examiner's expectation in the questions? Well, in numerical questions, he expects 100% accuracy. So that is something that you must get a hang of. You have to get the correct answer, and in limited space. For a 10 marker, they'll give you one sheet. Only in that. How many of you have given maths exams where you've taken sheets after sheets after sheets as those supplementary sheets that we get? Do you take supplementary sheets usually in maths? Honestly, when I was working in Delhi University, everyone used to fear invigilation duties. Any which ways, invigilation duties are pretty boring because, talking from a teacher's point of view, we also crib about things, that, right? So nobody liked invigilation duties, but everyone had to. Given a choice, nobody wanted to do maths invigilation. You know why? Because as per my senior teachers, answer sheet bahut mangte hain. So maths papers are very, because, in the entire, then you have to sign it, and then you have to give it, and then you have to tie it up, and then somebody's sheet will fall, and so it takes the most time. So that is how you guys also used to. Registers after registers, you must have filled up doing calculations and all that. Come UPSC, and there is a limited space that's given to you. Midway of the answer sheet, midway of the answer, you realize, oh, you've done a calculation mistake. What can you do about it? Nothing. You can only go back and change a bit, or use your rough answer sheet or rough answer space that's given to you to calculate, and then copy down the answer here. So one has to be very careful about first spending 1 or 2 minutes analyzing how you're going to present the answer. That's why I said accuracy is very important, but I mentioned earlier, I'm saying it now again. Accuracy is important, 100%, there is no doubt about it. However, presenting your answer is equally important. You cannot just show the calculations. Who is the examiner? Examiner is most likely a professor from a college or a university, somebody who's been teaching a particular topic for ages and ages together. Whatever college you were in, did you have specific teachers for specific subjects? Like, was there an algebra teacher who taught your juniors also and your seniors also? Or every year they changed the algebra teacher? Did you have one kind of a teacher? There were algebra faculty, there was analysis, there was probability. I remember in IIT, the professor who taught me probability and statistics, for years, obviously, he just taught probability and statistics. People just knew him as the probability teacher. Probability professor is here. His name only we realized much later once we started interacting with him. But that particular person or a team of 2 or 3 people at the most are checking your answer sheet. But you do understand that someone who's done algebra analysis in college and now been teaching probability for about, say, 30 years or so, has kind of forgotten the basics. So you can't just show the calculations. Also, just showing the calculations is never the question in UPSC. It is about presenting the answer. When they say calculate, no, comment whether the solution of the following system of equation exists or not. Believe me, this is an actual question from the previous year papers. They'll give you a system of equations, 2x plus 5y equal to 3 and x minus y equal to 7 or something like that. And they'll say, in school we have done solve. We can solve. Question is not solve. Comment whether the solution exists or not. If yes, find the solution. What normally students do? Oh, we solve it. We solve it and show the solution. Hence proved. Question was not solve it. The question was comment why the solution exists or comment whether the solution exists or not. So there is some theory behind it. So the presentation has to also be theoretical in that sense. And then calculations have to be shown. Like I said, accuracy is very, very important. I'm not questioning that. If your answer has to be 59.8, the correct answer is 59.8, your answer has to be 59.8 to get marks. But once your answer is correct, suppose the answer you're saying is 59.8 and the examiner has a, we have a answer key or something where we have solved or whatever. So we know this is the correct answer. I'll put a tick here. If it's a 10 marker, I've put a tick here. What does that mean? Do you get 10 on 10 here? No. What does it mean? It means your final answer is correct. So now the examiner looks at your presentation. As compared to, please compare this with the scenario where your answer is coming out to be 69.3. And I know the correct answer was 59.8. What am I going to do when I look at 69.3? I'll put a cross and I'll go ahead. I will not even look at your presentation. Most likely, I will not look at your presentation. Why? Because your final answer is not matching. Even if you made a mistake just in the previous step, it doesn't matter to me. How many hours exam do you have to give? A 3-hour exam. How much time do you think the examiner spends on correcting your answer sheet? Just guess, a wild guess. Do you think he spends 3 hours? No. 5 hours? No. 5 minutes? I wish that was true. 5 minutes is too less. Give me a realistic figure. Half an hour or so. Half an hour. And is he more likely to spend time on the answer sheets or more likely to skip through and quickly finish the work? In which the examiner has been forced to correct. This is nobody's choice. No matter how much money you give, nobody wants to correct answer scripts. That's the most difficult part of being a teacher. Making question papers, answering doubts, correcting answer scripts. And if you have to do it at a UPSC level, you have to also be very, very careful because it's a question of your prestige and the life of the student which is at stake. But half an hour, if I'm spending on it, I'm not going to spend half an hour on reading wrong answers. No? So if it's 69.3, most likely I'm not even going to look at your presentation. So that tells me, that proves that accuracy is important. But if your final answer is correct, don't expect a 10 on 10. Then the examiner looks at your presentation. Have you written the steps given, underlined it, and written it properly? Have you written what you have to show properly? Have you written the steps? We perform row transformations, and then have you given the reason? Because row transformations do not alter the rank or whatever is the reason. I'm just giving you an idea. Have you written these steps or not? If it is a 15 marker, your questions would be 10 markers or 15 or 20. It can also be 17, 12, but in the neighborhood of 10, 15, 20. For a 20 marker, it's a long question. About 2 or 3 sides of the page would be given to you. There has to be a break, no? There is like a milestone. If you're traveling from here to Chennai by road, would you go non-stop? There'll be some sort of where do you halt for the night? That kind of a thing should be visible in your theorems also. What is the in-between point that you've got? Have you highlighted it? Have you made a box out of it? Have you called it as equation 1 and said by 1 we get the desired result? Have you just written answer is this, or have you written what they were asking? What is the volume or something if they're asking? And then the final answer has to be like, okay, the volume of the given sphere is this. Proper answers have to be written. If you do that, there is no way people will not give you full 10 on 10. However, if your final answer is correct, but your presentation is not up to the mark, that means you've just done whatever, the tech trick, you've done this shortcut. Pascal's triangle, do you remember? You've just done something by Pascal's triangle, that combination, NPR, NCR, whatever. I'm just saying you've drawn some rough work and something. then out of 10, you might just get about 5, even if your final answer is correct. Also remember, there is no full transparency here. Are you going to get your answer scripts back? Is the examiner answerable to you? No. So if I've given a 5, it's not like college, Again, I get the deja vu feeling of college. You must be remembering haggling your teachers for why have you given me 5 here? Have you done that to your teachers? So proud of it. You're not supposed to be very happy for it, but you have done it. Why have you given me 5 and why have you given him 6? And maybe his handwriting is better. Maybe my mood was better when I was checking that. That's also possible. There is this human angle that has to come into picture. But my mood, I may not be in a very good mood, but when I look at your answers, my mood has to get better. Your answers have to be so good that the examiner has to withhold himself or herself to write a very good there in the answer. So beautifully written that I can't stop myself unless I write a good. This good is not going to be visible to you. But if I write a good in your answer, that means there's no way anybody can cut even half a mark in that question. That is a level of expertise that is required of you. Do you understand? And that does not happen overnight. If you pardon my language, and your answers usually are pretty filthy. Whatever, just integrate and written the answer and then that arrow going there and written something and we know this and you are applying some theorem. You're not telling me which theorem. Some answers are by theorem, we know that. Which theorem? By lemma B. Which lemma B? Where is the lemma B? I'm looking for lemma B, left, right, center. I can't find a lemma B written. What is the meaning of a theorem? What is the meaning of a result? What is the meaning of a lemma? What is the meaning of a proposition? What is the meaning of a corollary? These are the words that we discuss on daily basis. It's not like you have to cram it up. This is like language of maths. Maths, like I said earlier also, it's mathematical sciences. Why a humanities student who's predominantly good at language topics is able to do maths well? Because maths is a science, but it's also a language. How do you master a language? By talking about it, speaking, listening to it. You will be listening to me non-stop for 2.5 hours every day. But then you have to also talk back to me about it. What is the meaning of a corollary? Ma'am, how is it different from a lemma? Why is something called a theorem? Why is something called a result? We'll be discussing all this. This adds that beauty that is required for the love of the subject also. So you can't do something for a very long time if you're really not in love with it. I know you're not here to get your master's degree in maths or do your PhD. End result is very clear. You have to clear the exam. But if you like the subject, are you more likely to do well in the subject? Yes. If you like it, if you find it interesting, then you're more likely to sort of enjoy doing it for a longer period of time, which is what is required definitely in maths, all right? So these are the kind of things that I'll be focusing on in the class, with accuracy, with presentation as one of the pillars that I concentrate on. Concepts, of course, fundamentals, practice. Sometimes I make you do class assignments in the class that, okay, first 5 questions you do right now only. Okay, that gives me also a breather. I need to sit down sometimes, no, in between. Otherwise, keep writing on the board and solving. So when you do it, it's like a healthy competition. Somebody can do it in 5 minutes. Somebody is struggling to do it in 10 minutes, but that should not make you upset because everyone has a different style of working. You're listening to something for the first time. Even if you can't do it in the class, you have an opportunity to go back home and try it once more. Tomorrow, you may be doing it faster as compared to the person who did today. The idea is slowly and steadily your performance has to keep improving. All right? Is that clear to all of you? All right. So, yeah. Let me see some questions now. Let me just see if I've covered everything. I think in terms of syllabus I have, if you wanted to copy down, I can repeat it for you. But otherwise, you know the entire 13 modules now, just divided into 3 categories. What are the 3 categories we have discussed? Algebra papers. Okay, there is modern algebra, linear algebra, analysis papers. Where there is analysis, where is analysis coming? Calculus, real analysis. In fact, my booklet is called Real Analysis and Calculus. I do it together. Books are also like that. Real analysis books has calculus. The calculus books has real analysis. So it has to be done together. Calculus, real analysis, and complex analysis. Actually, just these 3. But I wrote numerical analysis also because it had a word analysis. For that matter, vector calculus has calculus. So there can be many subdivisions that I can make here. Then comes the applied topics. What were the applied topics? OD, PD, LPP, and numerical analysis, vector calculus. All right, 5, 6, 7, 8, 9, 10, Any one topic that I'm forgetting? Analytical geometry, yeah, 3D geometry. That is also a fixed kind of a syllabus, this thing. And then you have the two physics topics. Is the syllabus bifurcation clear to all of you? Like I said, we also proceed in that way. We don't do it paper-wise. I do it the way I start from algebra. Okay, I start with June batch. I begin with algebra first, because then you have an opportunity of clarifying your doubts till the end of, literally till end of March. By the time my second batch gets over, you're still that batch only in a way. You still have that opportunity. So I start with algebra. Should we start with the easiest of the topics or the most difficult of the topics? Most difficult, something that is considered to be toughest. If we can master that, then the easy topics we know are we are going to master. You're also very high on energy when you come for the class, isn't it? Look at the pin drop silence right now. That's not going to, like, you're looking at me all that very carefully, and I wish that continues. But in between, when you get tired, the classes, the GS is also there, and sometimes it becomes overwhelming, and your attention span also starts decreasing. I hope it doesn't happen, because you have to be very energetic in my class. I will actually make you work in the class, so you have to keep your energy levels high. All right. So if you have any questions, I'll take up one or two online questions I'll take up. Meanwhile, you think about what you want to ask me. Okay, the level of questions in exam with that of BSc Maths Honours, it's the same level. So the level of the exam question paper is graduation level. It's just the same. In fact, sometimes it's easier. Graduation is not asked at all. So BSc level. But when I say BSc level, there are certain topics that you've not done in BSc. Like physics is not now a part of BSc syllabus. It was when I was studying in college. But now physics has been removed completely. Also, there are many optional papers that have come up. So somebody may have done LPP, may not have done LPP, depending on whether you chose it as an optional or not. All right. But otherwise, if you ask me, the level of the questions is average. They don't ask extremely tough questions. They don't ask very big theorems. Five pages theorems also we have, they don't ask. They ask nice, pretty average level kind of theorems. But when I say average level, there are about 100 theorems you have to do in linear algebra. So how can you can't cram them up. So you have to know a way to do it. It takes time, but that's the only way you'll be able to reproduce it in the exam. So it's the same level. All right. How much time ideally should be given to maths along with the GS subjects to be studied? Like I said, my expectation of you is 2.5 hours classes every single day. Every single day. You miss a class, the bridge is broken. So, and of course, you'll probably have recorded lectures and all that you can look at, but every time you come for a class, the previous class has to be on your fingertips. Most likely it's going to be related. So you have to know it. And apart from that, I would expect you to put in 2 to 2.5 hours every day. Every single day. You're going to have one off day in a week. I'm sorry. You don't have any off days. That off day is for me. That off day, you'll have to sit up and do everything that has got pending, because there'll be pending work. So how many off days do you have per week? Say it loudly. 0. Okay? If you don't take it as an off day and take it as a day to cover up on the previous thing, that's the only way you'll be able to sustain. Okay? So you don't have any off days. You do have one day when you're not meeting me technically, at least one day. Sometimes I may skip that one day, and in the next week I can give you 2 off days, and I can give you a small test the next day. That test paper is not going to be collected. I'm not going to sit down and check everything. But it could be a mini class test based on the topics that we have done till now. So it could be like a 45 minutes test. And for that, you need one day to cover up, one day to prepare extra questions, because questions will not be directly lifted from the class. It will be related. So you have to be on your toes. It's like a military program. Okay. And I mean, it's not required, but let me just do the formality of saying that 100% discipline and attentiveness is required out of you. You are expected to do your assignments. You are not expected to come to the class without revising the previous lecture. See, it makes my life more tough. No, I have to. Ultimately, a teacher's job, our job satisfaction depends on you guys. That's very unfortunate, because the ball is not in my court. The ball, once I've finished my lecture, I will do it 10 times if you ask me to. And that reminds me of something. When I say you ask me 10 times, you can't say, ma'am, I've already asked you 8 times, so 2 more times I'll ask you. You don't have to go literal meaning of 10 times. But in the class itself, every theorem, for example, gets done 2 or 3 times. Because once I'm explaining, somebody is, giving some opinion, I might try it even if I know it's wrong, but I don't want to discourage, so I'll try. But then I'll tell you why my way was better. Sometimes I'll have to push you in the right direction also. No, I can't always expect you to know the answer. So pushing you, then you'll have to be reading from the notes, sometimes jotting it down also from the board, then going back home and revising. So everything gets done 2 or 3 times minimum. But even after that, if you can't do it, then the effort has to come from your end also. No? If there is obviously a problem, then after the class, I'm always available to answer your doubts. There is no problem about that. Even the online students, you have an opportunity of asking me through the doubt portal. But in maths, you can't give me like, okay, solve this 10 questions and give it to me. You can't do that, because every person, if you start giving me 10 questions each, I will never be able to do any justice to the teaching that I'm doing. But there has to be a collective doubt solving sessions that we do in the class, or a tests or assignments or things like that. All right. So yeah, coming to the last question that I'll take up online before I ask the offline students. I'll be doing all the maths topics, and one of my colleagues would be doing the physics topics. That colleague of mine is also an ex-student of mine with about 15 years of teaching experience in DU colleges. So she'll be doing the remaining physics portions, okay? And she's doing it in, so I'll be monitoring it. I mean, I know the notes and, we have made them together and everything, but she'll be sharing the physics load with me on that, all right? So that's the... How much time will it take to complete the syllabus? About 6.5 months, 6.5 to 7 months it will take me to finish the entire syllabus. But when I say finish, I mean from scratch to end. Test series you should join only after you have given the pre, honestly, next year. Because tests will be like sectional tests, but I'm not teaching section wise. So the enrichment program will be going on, but enrichment is after you've done the foundation course. No? My foundation course includes doing everything. First you do that. Then only you are eligible to actually sit down for a test series or do an enrichment program or anything else. First, you only concentrate on the classroom program. Okay? Any offline query, any doubt you want to ask me? Okay, think about it, because online students are asking. Anybody wants to ask me anything? Just check if there are any other questions. Okay. Yes, like I said, mechanism for taking the doubts, there's a doubt portal for the online students. I don't access it every day, but on a weekly basis, I would be. And also because we meet every day, so today's doubt, I mean, it's not expected that by tomorrow I will be able to answer it. But if you have a doubt, you can always, like the way you're typing right now, you can also say, and ma'am, yesterday this particular topic or whatever, then I'm able to make a sense of whether I need a repetition. Also, first 5 minutes, 10 minutes of the class, if it's related to the previous topic, does go in talking about it, because that's how we start the class. No? It's not mechanical. It's not like today we put a full stop here, tomorrow we start from the next line. We have to revise or at least go through the basics in that sense. So it's like I said, if you are attending classes every day, it will be like a continuous process. So if you can't solve something today, maybe 2 days later, you will be able to solve it yourself. I know which kind of questions require a little more patience. So sometimes I say that, okay, if you are not able to do it, it's okay, try once more. When I say try once more, I know today what I'm going to teach you will help you to do it, maybe in a better manner. Maybe it will give you another perspective. So then you have to be a little patient. Otherwise, I'll take up the doubts once the topic gets over. All right. Offline students, do you have any query, any question? Yes. No, it should not be skipped at all. See, about 25 years ago, people who had cleared civil services with maths as an optional, okay? I know 1 or 2 people who had maths as their optional, and they never did any algebra. No algebra at all. Why? Because the trend was, the style of asking questions was, question number 1 used to be algebra, completely. Okay? And then question number 2 is basically the whole of analysis. Question number 3 is the whole of vector. So you could have skipped one topic completely. But now, you also know maths as a static syllabus. They can't change the syllabus too much. So what have they done now? For the last 15, 20 years or so, they are giving questions in a mixed manner. What does that mean? So I hope the idea is every paper has 2 sections, section A and section B. Section A, question number 1 has 5 parts. That is 10 marks each. This is a compulsory question. Everyone has to do it. Then there is a question number 2, question number 3, and question number 4. Question number 5 is section B. Okay. This is also 5 parts, 5 into 10, And this is compulsory. Question number 1 is compulsory. Question number 5 is compulsory. Now, when I say compulsory, how many compulsory questions therefore? 10. And they are from all over. So this 5 questions will be, if I talk about paper 1, for example, there'll be 2 questions from linear algebra, 1 question from real analysis or calculus, and 2 from geometry. You can't leave anything. This was expected always. So 1 or 2 questions people used to leave. But now question number 2, 3, 4 also are asked in a mixed fashion. Question number 2, there'll be a 15 marker from linear algebra. There'll be another 15 marker from geometry. And there'll be a 20 marker from calculus. So you can't leave any topic. Similarly, coming to section B, this is going to have 5 parts. So it can be from ODE or vectors or physics. Similarly, question number 6, 7, 8 are now coming in a mixed kind of a fashion. So you can't leave any topic. The idea is to, in total, you have to attempt 5 questions only out of the 8 questions that are asked, out of which question number 1 and question number 5 are compulsory. How many questions are left? 3. You have to choose 1 question from each section. So you have to do 1 question from here and 2 from here, or 2 from here and 1 from here. So you can't leave out anything now, because even if you do only 1 question from here, suppose you say, okay, we'll do question number 5, maybe 2 physics questions, okay, 20 marks we are leaving, maybe. But question number 6 that you're doing can have a 20 marker from physics. And roughly every topic comes to about 50 marks. This will be analyzing more once the syllabus, once the course begins, because it's too sort of early to discuss all this. But roughly every module comes to about 50 marks, sometimes 40, sometimes 60. So, but you can't leave it because they come in a mixed fashion. So you can't leave the physics portions at all. But you can leave out very complicated applications of physics, because that, if it comes in question number 8, they can't ask it as a 10 marker. 10 marker also has a limitation of space now. There's only 1 page. So very classic questions are asked. They're not very difficult. 1 or 2 new questions are asked always here. But they're again not difficult. They are new things that people have not seen before, like magic square. I think 2 years ago they asked. Very simple, not difficult at all. But you haven't seen it before somewhere, you know. But that's expected because it's a compulsory question. So 1 or 2 questions they will give which are sort of new to the students. But they can't ask very complicated questions because of limited space. But you can't leave out any topic, like I said. All right? Which partition? No, this is not fixed. They keep changing it. This 2 linear algebra questions generally are asked, but then they can ask 2 questions from calculus and 1 from geometry. They can do that. It's not fixed. There is no transparency here also. You can't expect. See, what is a trend? Last 2-3 years, you look at the paper, you expect the same paper to come. It depends on who's the paper forming committee that year. If they have changed it, and there is obviously not going to be any transparency, this is the most difficult exam that you're preparing for. You know the syllabus of UPSC maths optional? In one line, if I have to say, it's the entire maths honors 3-year program that I used to teach in Stephens, plus a little more. I used to teach almost all these topics to all the 3 years, first year, second year, third year, combined together, almost in the same detail. Of course, some theorems like Riemann, we do 10 theorems. In honors, we do about 45 theorems. But which 10 have to be done, there is no clarity about it. The syllabus is written in a very generic sort of a manner. The Riemann integration. What do you do in Riemann integration has to be decided by the teacher, by you, by your level of understanding. And that's how, when you do foundation course, sometimes when you enroll for test series, I give questions which are slightly tougher, because then you have to push your limits. No? Once you have done the foundation course, I'll also be guiding you. What do I mean by pushing your limits? I'll tell you the 10% course that can be covered with a little bit more hard work in specific topics. Like, for example, somebody says, ma'am, I know linear algebra very well now. You've taught us, I've understood everything. Can you tell me extra things that I can study? That is where the book list comes into help. I'll tell you, okay, if you like linear, see, remember one thing. When you're preparing for some paper, right now, the stage you are at, you are working on your weaknesses. There is some amount of weakness in your preparation. There's some topic that you don't know, you're not confident. That's why you're here, no? See, anybody sitting here who's come here specifically for ordinary differential equations coaching. I don't even expect you to come, because I do OD in 6-7 days. Mostly you are here for algebra and analysis. That itself is about 50% of the crux of what has to be done. But we'll do ODPD also, because that also comes for, together ODPD comes for about 120 marks. 120, because 60 each, 60 marks each. So it's a very big thing, but it's not that difficult to do it if you practice right, in a right kind of a manner. So I'll be coaching you how to do that and all also. But having said that, you have to remember that the effort has to come from your end for sure. All right, I'll be there to guide you. I will be telling you how to go that extra bit, extra mile, how to do 10% more so like I was saying, this is the time that you're working on your weaknesses and also on your strengths. Someone says, but ma'am, I've done LPP, I know it very well. Very good. Do it once more with me. I'm doing it in 3-4 days only. I'll also finish it very quickly. Then that kind of a topic. So you are here to work on your strengths and your weaknesses. Do you agree? Ultimately, however, when you're giving the exam is the time to show your strength or your weakness. Strength. By that time, you need to isolate what your strengths are, so that when you glance at the paper for 5 minutes, this is the question you are definitely not doing. This is the question you are definitely doing. Why are you so confident? Because you think you can do it better than anybody else. You know it that well. So it is time to isolate your strengths and weaknesses also. So when you say, I know linear algebra very well, ma'am, can you guide me? How can I do a little extra there? There is a list of books I can suggest. There are some other things that I can tell you. I tell that to everybody. In the class, I'll say, these are the theorems I'm doing. This is a list of theorems I'm not doing. If you're very confident, please search them online or read the book or something. Do it. Because again, UPSC, there's no fixed, defined kind of theorems. It can ask anything. But if you're struggling with the basics, how can I ask you to do advanced? So that level of that discretion is left to you. All right. That we do in every topic. So I sometimes say that, all right, I'm not doing this theorem. I'm giving you an outline, but I'm not doing the proof. But if you're very confident, or if you're very sure, if you have all the time in the world, go back and do it. You don't have time, it's okay. Anyways, the chance of that question coming is remote. That's why I'm not doing it in the class. Things which are important are going to be covered in the class. But things which can also come probably, or maybe there is a remote chance, I will be mentioning it in the class, because that gives you that extra 10% to do at home also. No? Effort has to come from your end also. Clear? Any other question? Yes, Pranav, like I said, I will be doing it from the scratch, but I expect you to know differentiation, integration, matrices, determinants, school level. You don't have to open any college book. No fancy book required. Just basic. And a formula sheet. This is something that you must have made some formula sort of a sheet. But you need to also have I don't know if it's still for 5 rupees, but do you get any notebook for 5 rupees nowadays? No? 10? 20 is the minimum. How inflation has risen in the last 20 years. Because I remember telling my students to always buy the smallest size notebook that's available in the market. Nowadays, there's such fancy diaries also, and I have a liking for diaries, but I just buy some book, some notebook. And every day in the class, I promise you there'll be a new thing that you learn in any topic that you name. So you may say, oh, differential equation, I know very well. What can ma'am teach extra? I'll tell you some algebra there. You will not even have heard. I did not hear of it when I was a student. Even while I was teaching in the beginning, I didn't know if there was some algebra involved in differential equations. I'll show you how, or I'll show you some analysis there. I'll show you what is the meaning of that extra bit that you get in the class. See, notes is just 50%. No? It's like I said, it's not written by me. It is written. How do I explain it? It's written by me, but not invented by me, discovered by me, produced by me for the first time in the world. Somebody has done this. Who somebody? For 100 years, people have been doing the same Cauchy theorem, Lagrange's theorem. No? Are we the first batch who's going to do Cauchy theorem? Thousands, millions of people have done Cauchy theorem before us. But when we do Cauchy theorem, there must be some new thing that we must, some new perspective, some new idea, right? And that kind of a thing must go back in your diary. Any formula that you come across, which you didn't know earlier, any shortcut that you learn in the class, you must have a small notebook where you go back home and write that down. End of about 6-7 months that you're going to be there with me, that notebook will be full. I assure you that. And if you have that booklet, that's your revision. See, booklets of this size, about 10 booklets will be given to you. I can give you double the volume also. The idea of giving you notes is to increase your work or decrease your work. Decrease. Why will I? So idea is, I can give you double. I can get photocopies of some books, or maybe just write it down and attach. I can make every booklet double. We need to give you knowledge in a compact manner also. No? Easiest for me is to say, look at the book list I've given you. If you can buy all the 13 books and know them by like the back of your hand, you'll be able to clear the exam. That's easier said than done, no? That's like saying go to the library, read everything about everything, you'll definitely become a civil servant. You have to tell me what is the just the right judicious amount of work that I has to be put in clearing the exam. So my work here will be to reduce the burden, but not the effort. I can reduce the burden by telling you what is important. I will teach you the concepts. I will expect you to do the assignments. I'll help you with the assignments. So effort has to be coming from you, but burden will not be there because choosing the right material is not your problem. That is I keep adding. Every year there are more things that I add. Sometimes the booklets I've got prepared, I give you some handouts separately because I feel that this theorem also, we should do it like this instead of doing it like that. Or some new question I feel that should be shared with students. So there's some handwritten notes also that you'll get. On the board I don't do questions from, turn to page 448, let's do that question. That question is solved. Let's do something else. Let's change the question a bit and see how it happens. So there are questions from the booklet that we'll be doing, but there are also new questions that we'll be doing in the class. All right. So the effort has to be, it's like a team effort. Right? Each person has to know their role. And there are only two people in the class. Who are the two people in the class? Me and you. It doesn't have to depend on anybody else, actually. So if you are doing your work, I'm doing my work, the result has to come. But it's a slow process. If you're expecting in 6 months, anybody expecting in 6 months I'll become a master mathematician and therefore get a 500 and 500, please go back because you are in a wrong place. I'm not going to advocate. You can't get more than 350. A healthy number is 300 plus. 350 is quite possible, plausible with the right amount of effort. But don't expect magic. Okay, it doesn't happen like that because there's a lot of GS you are studying. Maths also, the UPSC makes sure they are giving you questions which are sometimes twisted. My students need to know when not to get into trap of twisted questions. You're not trying to complete the entire paper. You are trying to clear the exam. There's a difference between the two. So I will be coaching you in between as to how to choose also a correct question. If you choose a question, every question is 50 marks. Question number 1 and 5 are compulsory. Compulsory means whatever you can do in that, you have to do. Question number 2, you choose without looking at part B and C. Only A you knew very well. But that only will give you 15 marks at the most if it's a 15 marker or 20. Another question number 3, you knew part A also, part B also. One was 10 marks, another was 15 marks. That way you're getting 25 marks. And so you have to have a process of elimination also associated with how you're going to attempt the question. In the questions that you can't do, what is the best way to get some marks out of it? Because like I said, human beings are checking your answer scripts. If you've written some answers beautifully, and in one answer you haven't really gotten the complete result, but it's still making sense, there is a tendency to give some marks, no? What is better, 2 out of 15 or 0 out of 15? Don't say 15 out of 15. I know that's the best scenario. I'm saying which is better, 0 out of 15 or 2 out of 15? Then start comparing what is better, 0 out of 15 or 8 out of 15. Definitely 8 out of 15. But how do you get that 8? That I'll tell you. In the questions that you can't attempt, what you can do so that you can snatch marks. Because step marking, there has to be some amount of marks. Provided your answer is making sense. Don't play over smartness. If there's a theorem and you write down given and to show, again write down given, again to show, and some story, the examiner knows what you're doing. Okay, we all know, we have been there, no? I was a student once. So I'll tell you how. Don't write anything foolish. Instead of writing anything foolish, it's better to leave it out because then your entire impression goes down, of the entire paper. A paper is a representation of you in front of the examiner. You can't face the examiner. He cannot talk to you. He cannot ask you. So your answers have to speak for themselves. So you have to write beautifully. Like I said, mathematics, it's an art. It's a language. It's accuracy, it's technical, mechanical, yes, but it's also a form of art. You can see an answer which is beautiful, an answer which emerges on its own. Starting from absolutely nothing, you get a result. The beauty of that has to be appreciated once I'm done with that. All right, test series. Yeah, you can only join test series also. But like I said, test series have to be done once you have finished the syllabus. So test series program is a separate program. I'm talking about right now a foundation thing. No, there is not a test after each topic evaluated by me. That is impossible to do. There are tutorials in the class that I do. I share answers and all. Test series is a separate thing where I check answers. In classroom program, I can't do it. It's impossible. Yes, 12th level integration and differentiation, trigonometry, etc. You're asking me something? Yeah. See, because the thing is, so he's asking me if the answer is not matching, you said that the examiner would not give you any marks. See, I have to prepare you for the worst scenario also, no? I can tell you, no, you will get marks. And what is the point of also, I can't sugarcoat things for you. Reality is that you may not get any marks. However, not every question is a numerical question. If it's a theorem, there is no right or wrong theorem. There is a way of presenting the theorem. Like if you know the proof also, even then your proof can be very different from your proof. It's like writing an essay. You're writing an essay on the same topic, but does everyone get the same marks? A theorem is almost like that. I know there's a difference because it's more objective. It has to make sense first. You know, your theorem has to be proved. But still, there is a way of presenting that the fine nuances and the nitty gritties you'll be able to appreciate only once I start teaching. I can teach you right now a theorem to show you how what I think is beautiful, why I think it is a beautiful theorem. But you have to find it beautiful. No, me finding it beautiful is not going to help you. So I have to develop that foundation in you. So I was talking about how to get some kind of marks in theoretical kind of questions. And in applied questions, how to minimize the silly errors or the mistakes that we do. At least your presentation has to be up to the mark. Then if the examiner sees that, okay, if there's a long question, in between you have got one box which is correct. It was two questions. Find the rank and then find the solution. At least your rank is correct. But the examiner can't see only anything. It's looking like one whole lot of things, one written after the other. Then examiner is not going to give you marks. But you have got the rank and you highlighted in a box and underlined. Then my eyes will have to go there, and if it's correct, I'll have to put a tick mark and then give you some marks. These are kind of tricks that hardly a trick. It's a common sense thing, but when we discuss it, it becomes a part of your character. So you learn how to present the answer like that. All right. Okay. Yes, test series will begin. You can check the website for details. I don't know exactly the date, but there'll be a test series for sure. A group for maths. Okay, can we talk about making a group once the classes begin? Because if and when we do make a group, it has to be a group without good morning and good night messages, and there has to be a sort of a level of decorum that is expected out of everyone. And I'll be secretly a part of the group, never responding to anyone. But you do any sort of a wrong message, you're going to be thrown out of not just the group but the class also, because it's my responsibility to see that nobody is harassing the other student here. And yet in maths, we do require a platform where I can't solve every integration. Every day if you come and say, do one integration for me, that's going to be impossible. So there'll be some way that we do, but it's going to be a very closed thing. Okay, that we'll discuss once the classes begin. I think these are the nitty-gritties we can discuss later. All right. Any other question from the offline students? Please locate if there's any question that I've not answered. Test series I've already answered. As an offline student, what is the last day to register? Please check the website. I myself don't know. All these informations will be available. Fees please check on the website. Okay, scaling, someone was asking me even earlier. See, things that we don't know of, we'll not comment on. Is the system transparent? Are you going to get back your answer sheet? No. I know, I can tell you one anecdote for sure, and this something happened. In my first year of teaching UPSC, one student he was not very happy with his performance, and he was cribbing about UPSC checking and everything. He said, I should have got this much, but there's a scaling and my marks got reduced, and he's very hyper. I told him, all right, cool down. Let's see where you've gone wrong. What are the things that you are, he had given, I think, 3 attempts already. And got about 200 marks, even 280 he touched once, but never touching the 300. The golden marks that are required to clear this exam is 300 plus in optional. In maths, it's very simple to actually get 300, but he's at 280, then 204, then 254, something like that. So he's cribbing about because what we don't know, we end up blaming that. We can't blame ourselves. So he said, no, but last year paper was definitely very nice, this, that, whatever. I told him, okay, why don't you solve the paper and bring it, I'll see. There was one 18 marker, and when I teach linear algebra, I always remind people of this story because it happened in front of my eyes. Okay. And this guy said, this question I definitely know, 18 marks I should have. So when I was discussing the paper with him on an individual level, I was mentoring him for his next year. So he knew the syllabus, he'd already covered it 3 times, he's given the mains. So I was discussing, and he said, in this, I should have got 18 on 18. See, here, I should have got this much. And I'd asked him to analyze the paper for himself, how much you should have got. Then I asked him to solve the paper, bring it to me, I'll check it. This 18 marker where he's given himself 18 on 18, he's made a gross error in the beginning, a fundamental wrong mistake. Even if then the answer is coming right, it was a slightly theoretical thing, so there was no right answer, wrong answer. But in the first line, the comment that he had written was so wrong that the examiner would have given him negative marks, if not 0. If I was the examiner, I would have given him minus 18. Of course, that's not allowed. But he never realized it till the time I checked his paper. Once I was able to prove it to him, then he understood that, all right, sometimes we come back from the exam hall thinking, oh, I've done this correct, this I should have got full marks. I'm getting, now 20 marks is a lot of difference. What you're expecting, and that is one question I'm checking. After that, I did not check the entire paper. This was question number 2A or something. I didn't check the entire paper because I said, if in one question you can go so wrong, imagine if I'm checking and 50, 60 marks difference I can get. That is equivalent to the scaling rumors that we hear. Don't, and please don't ask me at least. Even if you want to, the toppers talk and the toppers strategy and this strategy and that strategy, you guys have all the time in the world if you're reading all this. Some people also come online and say, no, there is a 0.7 ratio. How do you know? Have you been appointed by UPSC to tell you this? And if there is a way to find out, that should be transparent, available to you also and me also. Is there anything available from UPSC about what scaling is? No, but you hear these very confident people coming on the board, coming on the platform and saying, I know 0.7 has to go down and this is my analysis and this is... These are the very, very people who last year were struggling to clear the exam. Once they cleared the exam, the confidence level, it seems as though they were always confident. They were like you. They were like us, starting from the scratch and rising. Once you rise, you should not forget that you were a fresher once, with no idea what the scaling is. And even if you've cleared the exam, you have no idea what the scaling is. You cannot be sure. I, as a teacher, cannot be sure. How can you? So should we go into the domain that we're not clear about? Forget it. My answer is, if you're in the top 10% without scaling, then you're in the top 10% with scaling also, no? Are you trying to be the bottom 10% or top 10%? Try to be top 10%. Even with scaling, you're going to be in top 10% only. How does it matter whether you have a 8 out of 10? You know, in IITs, we have the CGPA system. Anybody from IIT here? All right. So when you have from a system which has a CGPA, even the grading systems that you have, but I remember this one topic, and I'll not name the topic. I had an A grade. However, I didn't expect one. You know the marks that I got? Should I share it openly? You will not hold it against me, no? 8 out of 25. Still, I got the highest grade. Why? Because it's a top mark in that paper, in that particular group. That happens, no? 8 out of 25. I was petrified, mortified. How do I look at it? I'm from DU, Delhi University College. And you can almost predict what the paper was. You knew the list of guideline questions. This Delhi University people, raise your hands if you're from Delhi University. Yeah. We have that list of guideline questions. So the guideline questions are 10, 11, 12, and 14. I dare to ask you question number 13 to any student in DU, they will not know. Because that's not in the guidelines. They don't even look at any question which is not in the guidelines because the entire paper comes from the guidelines. That kind of a person, if you reach IIT, where nothing is from guidelines, where the teacher gives you an open book, open time paper. One of the professors used to come and say, the test starts now, when does it end? When you wish to. You can sit there for 7 hours if you want to. Did you have an open? It was like a cultural shock. Then in the next paper, he said, you can bring any book of your choice. We were very happy. You know what we did? No, ran to the library, issued every possible book. He said you could also share the books with each other. We would get full marks. Amongst the 25, 30 people, we would. You know who made the question paper? He himself. From where? From here. He used symbols like this. If question mark is double question mark and something he wrote here, something, we didn't even understand if the question was from our topic. We asked him, is it for us or is it for someone else? He made the questions himself. That's why he said, no, bring any book, because the questions were not from any book. The topic was not from any book. He explained one definition. The classic way he used to give a paper was, he'll say the definition of a, suppose, I mean, this of course he taught, but suppose he said definition of a module. And then he defines it in the paper. This is question paper. Then he says, prove that this is a module. He's not taught us module. He's given us the definition of a module. Just sit down and show now it's a module. So in the book also, if you open, they'll give you a definition of module, but they'll not solve how to show it's a module. You have to understand the definition then and there. Now, this kind of a thing, what I'm trying to explain is that an 8 on a 25 can be the highest mark that is given in that particular question. So the scaling or not the scaling, it does not make any difference. Forget about the domain that we don't have a clear, transparent picture about. But if you are in the top 10%, then you're clearing the exam. Just remember that. In terms of optional, at least, the scores that you're getting, whether they are after scaling or without scaling, it doesn't matter. If you were the topper, without scaling, you're still the topper. With scaling, because everyone, do you agree it has to be done in a homogeneous manner? It can't be that I don't like you, so I'm not going to, I'm going to give you more moderation. I like you, so I'm going to give you less. That can't happen. There has to be a homogeneous decline. So whether 8 on 25 is treated as 8 on 25 or 25 on 25 to get an A grade, it's the same story. It's the same story. So don't worry about scaling at all. Okay? Don't worry about the toppers in the past. I hope we can get a topper from you guys. Shubham is asking me my qualifications. Well, I would say I'm qualified enough, but I had mentioned what my, yeah. Don't ask me redundant questions like, ma'am, is coaching important? I'm here to talk about my classes, but if you ask me an honest opinion, well, coaching is then not required for anything. When I cleared my IIT exam, I did not have a coaching, but then it does help you to have a disciplined approach to studying. And out of 13 topics, you may know 8. You may know 8. It's possible. What about the remaining 5? And everyone else is doing the all 13 topics now. You also see who you're competing with. And that kind of a discipline. Do you have that kind of discipline to study 5 hours every day on your own? And topics that you don't know, because then you don't understand. See, what do you like? You like things that you understand. If you can't understand something, can you like it? No. First, you have to understand it, enjoy it, then be able to do it also in the exam. If you are not able to reproduce it in the exam, what's the point of liking? You can't say, I like maths, but I don't get marks in it. Have you ever come across someone who says, I love maths, but I flunked maths when I was in class 10th? It's not possible. If you liked it, you would have studied enough to pass it, for sure. So you can do it without coaching, but the amount of discipline that's required is huge. Yes, recorded lectures are given. You can check the website for details. I think it's given for about 2 to 3 days. I'm not sure. Time period to cover whole syllabus is about 6.5 to 7 months, like I said. Yes. Any other question? Offline students, do you have any query? Yes, a scientific calculator that is non-programmable, something like Casio FX991 is allowed. Calculator is allowed. Lesser the number of students, better the optional. Is this statement true? Maths has not too many students any which ways then. It should be then favorite amongst everyone. See, which optional, don't go by any trend. Trend can change. And every optional is as difficult or as simple, I would say, because things that you're not familiar with, you have to see if you're doing some other optional. Let me not name the subjects, but if you're doing any other optional, that also you have to start from scratch only and compete with people who probably have an honors degree in that or have been studying for 2 years. So maths is not tough for people who like maths, no. Like, what could be tough for you? It's a personal liking also. Of course, anybody who has a doubt whether, is there anyone, okay, how many people amongst the offline students who are present right now have made up their mind about maths optional? Please raise your hands if you're sure that you're taking maths as an optional. All right. So some people are not sure. For them, let me tell you, there are 2 or 3 parameters that you should keep in mind without any doubt before choosing an optional. One is, of course, your interest in the topic, okay? And the passion for it, in the sense that, are you ready to work hard in it? Now, don't say that, I mean, I know the subjects. It's right on my tongue, but I don't want to name the subject. Some people say, oh, that optional gets done in 3.5 months. I should do that. Maths is taking 6.5 months. You have to devote 2 to 3 years of your life in clearing the UPSC exam. Let's be very clear about that. You'll be damn lucky and 1 in a million if you do it in 1 year. GS will take time. Optional will take time. In 3.5 months, you can finish the syllabus with the teacher. What about competing with people? Everyone has done it in 3.5 months now. You're competing with people who have done it for 2-3 years also then. So it doesn't matter how long does it take to finish the topic. The parameters that help you to decide are your interest, your passion, and are you willing to put in the hard work? Whatever hard work is required of that particular topic. For maths, like I've already explained what is expected out of you. To attend all my classes, I'll do every tiny bit of the syllabus in the class. And if I'm not doing something, I'll be telling you that, okay, this particular topic, I've explained the basics, now you go back home and do it. By tomorrow, you should be knowing that. Okay? So we do everything in the class, but you have to go back home and put in the effort. If you're ready to put in that effort, if you have a basic flair for maths, basic flair, you understand what I'm saying, no? Sometimes has it happened that you've been doing maths and you didn't even realize how much time has gone by? School level, see, till school you were all good. Then college happened. And then what happened? Semester came. And then what happened? Oh, 6 month semester. Technically, it's only 4 months. First month goes into fresher. Last month will go into farewell or something, or some college fest in between. Then 1 or 2 tests you do somehow. Convert the test to assignment. Ma'am, can we do a homework? Can we do this? All that. Remember, I've been a teacher in college also. Oh, what a life. 55 minutes lecture, 10 minutes you can take attendance, 10 minutes you can talk about something. I'm not saying that work is easy, but I can definitely tell you are preparing for a competition exam. It's a competitive exam. It's not like college. You can't take it like the way you did it in college. Huh? The last minute, how many of you have ever, for one paper at least in your college graduation, 10 days before the exam found out what the syllabus is and photocopied all the notes? And raise your hands if you've done that for any paper. Forget about maths. Maths, I know you've been studying every day. I know. You're very good people. Raise your hands. Oh, come on. Yeah. See, almost everybody. And what is this? It's like, I want to raise my hands, but I don't want to spoil the impression. I already know that you've done this before. You can't do this with this exam. In college, you could have done it. We all have done it for one topic or the other, maybe. Maths or not maths. And sometimes the teacher is very lenient. So then you get by. Sometimes the question paper you can predict. I mean, we did this, that we had a list of some 45 questions. We made, the teacher agreed to give us that list of 45 questions. Out of those, she'll give some questions. We begged and pleaded for the internal assessment to tell us the 10 questions that can come in the exam. And that's like, that's too much to expect. There's no internal assessment here. If it was in my hands, I would make sure everyone gets full marks. Is it in my hands? No. It's like an external examiner who's checking your answer script in comparison with thousands like you who've put in the effort. Okay? So we will not talk about scaling and the luck factor and anything else. We'll just put in our effort to the best of our capacity and then just hope that it's going to give us the result. All right? Study material, like I said, will be given. I've answered almost all these questions. All the maths topics are covered by me except for the physics topics, which my colleague would be covering. Not really mini tests, but every topic that gets over, you will be able to judge yourself also how you're performing in terms of how many questions in the assignment you're able to do. And then, of course, there is a test series program which is separate. It's not included here. Like that. Any other query, any offline, any student wants to ask me anything? Yes, ma'am, no, ma'am. In a particular direction, you can move your head. So I know that I have to wind up. All right, let me just see if there are any question that I'm not answered. Recorded lectures I've answered. Test series I've said. Okay, just go to the current. Any question if I've missed, and if you want to ask me, please type it right now. I'll give you about a minute. because I think by the look of it, I've answered almost all questions. Offline students, if there's anything you want to ask me, please feel free to ask me right now. Yes? Any doubt? No? All right. So there is no word limit, there is space limit, because in integrations when you're doing, or when you're presenting your answer, which is a numerical answer, there cannot be a word limit, but there is a space limit. So they give you, for 10 marks, they give you one sheet. For 15 marks, they give you one page, that is front and back. For 20 markers, sometimes 15 markers, they give you three also, depending on which question. If it's LPP and simplex method has been asked, or transportation or assignment, where a table has to be drawn, and there are about 10 tables you have to draw. So then they'll give you enough, there is always enough space. And in that space only you have to cover. So there is no word limit, but there is a space limit. Okay, within that you have to cover. There is step marking in UPSC, like I said, but provided your answer is correct. Let's look at like that, Yes, hard copy will be provided to the online students also. You will get booklets by post. Give us like 10 days or so after the classes begin, but we'll try to do it ASAP, because admissions have to close before the postal team can come into picture. It has to be dispatched together. You will get it. Meanwhile, you will get the copy online. So you'll be able to access it. You're asking me to help you make a choice between maths and geography. Well, to answer honestly, geography was my least favorite of all subjects, always. So don't even get me started on it. I don't think I'm the correct source person to answer on other subjects. Geography, no, maths. I don't know anything about geography, so that's all I can say. But yeah, and you can't really say that it's working professionals or not. You need to put in the right amount of effort. I think that is required. Once you're able to do that, get a hang of the subject, then like I said, maths is a way to go forward. If you ask me, I'll obviously say maths only. What else do you expect me to say? Yes, any other question? No, I don't think there is enough time. So you basically do my notes and you do all the solved and unsolved questions from the notes. They are enough. There are many solved examples. Look at this. No? This is about this modern algebra book. Last year, this has 263 pages. This year it might go up to 270, or it might become 260. If I think once something is repeated, I might, it's about 270 pages of theory and some questions. So if you can do solved questions and unsolved questions in my booklet, I've chosen the questions from different books. There's not one particular book that I follow for anything. So for modern algebra, for example, of course, you can check the website for book details, but I followed Gallian, followed Herstein also. I followed for linear algebra, Fredberg, Schwarm series. There are several books. So every nice kind of question that I can find, and then they are categorized. See, the idea is to categorize questions. I've given them already. Together with this, if you can do the PYQs, you don't need anything else. To add more questions, this is my job. So I keep giving you what I think you should do. That's why you don't have to consult too many books. You just do my notes and PYQs. You are, I think, sorted. More than sorted, I would say, because we do a little more only. It's a competition exam. I also understand there's no fixed guideline. So, you try and do all the categories of questions, all right? Pardon? If you do this, I can guarantee you 300 plus. This can easily be written as 350 plus, but then I can't comment on your style of writing till now. I can just say that if you follow the tricks and techniques that I'm trying to empower you with, it's about empowering yourself, because which question will come in the exam can I predict? Can you predict? Can anyone predict? See, after the paper has come, I can say, oh, these questions are from my booklet, but they will be, obviously, because my booklet is from 5 books. So, and those 5 books are consulted by people who know their algebra, they know their analysis, somebody who's teaching analysis in Delhi University for past 20 years. I know which books they follow, so I know those books. I know I followed those books also. So there will be questions, but then how do you know that you have to focus on those questions? So I can guarantee you about 300 plus if you follow this, but not everyone will get it. It depends on how you imbibe, how you practice, how much effort you're able to put in, obviously. Yeah, all my booklets are idle answers only, I hope. They're written nicely, so I hope they are idle. I mean, yeah, these are idle answers that you can write in the exam. These are like pretty good. I mean, I think if somebody were to mark me, they would give me good marks. All right, so getting too technical about 360 plus how you can get, definitely I can say 360 is also not a bad idea if you just follow this. But then what is your temperament the day of the exam? Are you a nervous wreck? Are you anxious? Have you made a careless mistake like 2 plus 2 is been written as 5 and gone wrong completely? I can't comment on that. Anywhere between 300 to 350 I can hope you can get. But don't ask me like, ma'am, 374 how can we get? And that is if you do 374 marks worth correct answers, that's how. So let's not it's nice to see the enthusiasm, but let's remember that there's a lot of effort that you have to put even to cross. There are people who get double digit marks also. Let me remind you of that. Okay, in maths, the people who get that also. So they've cleared the prelims, they've reached till the mains, then they've got double digit marks, 99 combined in paper 1 and paper 2. That's also possible. Of course, it's possible. No? They've not prepared, they've not done their job nicely, they've cleared the prelims. But clearing the prelims is a different ball game. It's difficult. I'm not saying it's easy. It's difficult. It requires a different level of preparation as compared to preparing for an optional. Like optional requires a different level of working as compared to, say, preparing for an essay program. That requires a different level as compared to preparing for your GS. There has to be strategies for each one of these and strategy for interview. There are stages that you have to clear. When I talk about optional, your stage 1 is to first do the foundation well, get your fundamentals correct, and also kind of fall in love with the subject. You can't do it in a dry manner. How can you do something for 8, 9, 10 months and not enjoy it? To also learn how to enjoy the subject so that you can put in your maximum effort. And if you do that, honestly, I don't think there is any limit to what we can expect in terms of marks. Anita, please check the website for it. But I guess if the admissions, I think the admissions are open now. They're open now. And last date, 15th, the classes are beginning. So I say the last date is 14th. You can come on 14th. 15th, don't delay it after 15th, obviously, because first a few classes are the, like I said, we only do examples in the first 2-3 classes. But those examples form the backbone of everything. I might pick up that example 1 month later also. So obviously, if you've made up your mind, you should enroll faster, right? Good evening. Honestly, I've answered that question about 2.5 hours of class, 2.5 hours from your own sense. All right. So if there are no more further questions, then I'll wind up. Offline students, do you have any query again? You're pretty shy as compared to the online ones. They've been asking me. Yes. Yeah. It's completely realistic because let me tell you that there have been times in the classroom, and this is an honest review, people with maths honors have done a lot of algebra. They know group theory, they know ring theory, they know linear algebra. Like, it's one paper in every semester. Sometimes 2 papers also. Group theory is split into 2 and so on. But once it is done in the class and a test is taken or something, I end up realizing that an engineer who has never ever heard of group theory ends up doing better in algebra as compared to someone with a maths honors degree. Similarly, maths honors people are not that quick at integration and differentiation, but they can learn. So every topic that I do in the beginning, when I start my classes, I'll tell you roughly how many classes I'm going to devote to that particular topic. That duration is assuming people don't know anything and taking up to the level that is required. In between, the hard work that you put in helps you decide how you're going to fare in the paper. It's a very realistic timeline. In fact, it's not short at all. I'm not doing it in a capsule sort of a manner. I'm taking enough time. Like, the topics have to be done at leisure. There's not going to be like a fast forward button. Obviously, sometimes people say, well, ma'am, this was done too. See, I can't, there has to be right amount of speed for everything. It can't be too slow and repetitive and boring, keep solving questions. Don't expect me to solve 100 questions in the class. But expect me to give you all the concepts that are required for you to enable yourself to empower yourself to do 100 questions on your own. If you're ready to put in that remaining, so if every class is 50% work, what you're doing with me is just 50%. Remaining 50% has to be done at home. My 50% in the class will always be 50%. Like, my work is always going to be full. Okay. What you do at home sometimes will be 50%. I'm able to do everything today. No, but I'm not well today. I could only do 10%. 20%, then wait for that off day that you get so that you can cover up, because all these issues have to go simultaneously. It's a very realistic timeline, but it has to be consistent. Every single day of the program, you're going to be working. Okay? Only if you're ready to put in that effort should you enroll. Because today you're coming, tomorrow you're not coming, 5 days you're off, 2 days you're coming, not preparing, not doing the assignments, then I can't do anything. But if you do it religiously, it's like the only duty that you have, then very realistically speaking, this can be done. It has been done in the past. People do it even in shorter time, sometimes in longer time, but I do it in just the right amount of time. There is no, like when I say 6.5 months, it can be plus minus 5 days. It can be plus minus 10 days, depending on how the class is going. Okay? But it won't cross the time that has been written. All right. No, basic knowledge, I have already told you what is required. Nervous for prelims, all the best. People who are, I can see some of my ex-students, all the best for your prelims. This is not the time to be nervous. This is the time to work on your strength. Let others think about strength and weaknesses right now. You guys, please, people who are giving prelims this year, should focus on the prelims right now. Then you can strategize as to how to do better after the prelims, not right now. All right. All right, then, if there's no other question, then I'll sign off for now. All right, guys, thank you so much. Thank you.